Hi guys, welcome to Parabolas. We are back to Parabolas, but within our conic sections. I wanted to throw back a little bit because I'm making this video on a Thursday, so Throwback Thursday. I don't know when you're going to watch it, but that's fine. But this is how we used to write our parabolas in vertex form. So we had the y equals a times x minus h squared plus k. So remember that we called that vertex form because you could just look at the h and k and you could tell that's where the vertex was. So up till now in all our conic sections, we've been doing something similar. We've been using h and k to stand for our center. Well, in a parabola, you don't really have a center, so it's still going to be the vertex. We're just going to write it a little bit different now, just to kind of match the other conics a little bit. So we're going to rearrange this. We're going to call this our standard form now. So all we're doing is actually subtracting k over with the y's. So that's how I got this y minus k here. And then instead of using a, I'm going to divide the a onto this side so that I end up with the x minus h squared by itself over here. And then instead of writing a though, or like 1 over a because I've divided it, I'm going to write it as 4p. So technically, you don't really need to know this, but a is really 1 over 4p. You're not really going to use that, but that's how we're rewriting this, just FYI. Okay, but we wanted to write it like this because there's a few things about the parabola that we're going to add on, like a few more properties. So you know how a parabola, normally it either faces up or down, like this. You know how all the other conic sections, except for the circle, we had a focus point, or foci? A parabola also has this focus point. There's only one, so it's not going to be foci. But there's a focus in it. It's just a point within the parabola, kind of like how our hyperbolas work with the point inside the hyperbola. And that'll be our focus. There's one more thing special about our parabolas. This is called a directrix. So the directrix is actually a line, and we always use a dotted line to represent it. So this line and the focus are special because every single point on this parabola is actually equidistant to both the focus and the directrix. Now, if I drew this parabola better, you would be able to see it a little bit better. Basically, what we're saying is, even if I chose, no matter what point I chose on this parabola, let's say this one, this distance here versus this distance here should be exactly the same. Obviously, I'm bad at drawing, so my distances don't look like they're the same, but they're supposed to be. If I chose this point over here, this distance from the focus and this distance to the directrix, again, should be the same. Oof, these are bad lines that I'm drawing. Which also means that the vertex of our parabola right here should also be equidistant from the focus and the directrix. So that means this distance here and this distance here are exactly the same. And you know, the vertex is special. So that distance itself, that's what P stands for, right here. So that P is the distance from the vertex to the focus, or from the vertex to the directrix. Okay, so that's what's special, the new stuff that we're adding to our parabolas. And then for now, we're going to write all our parabolas in this form right here. Okay. I'm also going to make it just slightly weirder. So you know how with our hyperbolas, depending on which letter x's or y's was positive or negative, it determined which direction your hyperbolas faced? Parabolas are similar. So right now, our x's are squared, because if you square the x's here, the y's stay not squared. If we square the y's instead, So I'm just switching the x minus h and the y minus k. If I switch those spots where the y's are squared, you're actually going to get parabolas that go sideways. Pretty exciting, I know. So then the focus, again, ends up being inside the parabola. This is the vertex. And then your directrix is actually going to end up being a vertical line. So think about it as the directrix will never actually touch the parabola itself. So whichever direction your parabola is facing, the directrix has to be on the opposite side. So if your parabola is facing up, then your directrix has to be underneath the parabola. So they'll never actually touch or cross. Okay, so let's do an example. We want to be able to write an equation in standard form for the parabola described. And in my first example, we're going to have the vertex is going to be at 2, 6, and the focus is going to be at 8, 6. So, first thing, as usual, for a visual person, I like to draw this out. Bam, there's my graph. Okay, so when I'm drawing it out, I also like to label things with a V and an F because they told me it was a vertex and a focus, because that helps me. I know the focus has to be inside the parabola, the vertex should be, at the bottom of the U. So if you look at this, you should be able to tell if the focus has to be inside the parabola, that means my parabola should be facing this way, like so. I'm just going to do a quick sketch. So that the focus is inside the parabola and the bottom of the U is where the vertex is. I obviously draw really well because, these points are supposed to connect, but whatevs. Okay, so knowing this, if it's facing to the right, then that means the equation that I use has to be the one that faces to the right. So that means my y's are squared. So I'm going to jot that down first, just so I remember this is the one I'm using. Okay, so then we just need to figure out my h and k and my p. H and k just stand for the vertex, so I already know my vertex, it's at 2, 6. So I can just fill in those numbers for my h and the k. And then remember, inside the parentheses, you got to do the opposite sign, like we've been doing all chapter. And then the focus was at 8, 6. So remember, we're trying to fill in the p. P is that distance from the vertex to the focus, or from the vertex to the directrix. So if we look at our graph here, from the vertex to our focus, that distance right there is supposed to be p. So here, I can just count out. This is 6 away, so that means p equals 6. So knowing that, now I can plug it into my equation. So I plugged in my 2, 6 for my vertex. I have 6 for p, so I'm just going to multiply this out. Okay, there's my equation. The one thing that you have to think about is, because my parabola was facing to the right, this part, 4p. Remember how we also have like a way a, when we talked about a up here, that was what determined whether it faced up or down. Same thing with the right or left. So let me also jot this down. So p is going to be negative if your parabola faces down, and if it's a sideways one, p will be negative if it faces to the left. So think about right side of a graph is always positive, left side is always negative. So that's something you can't determine just by looking at the graph. So we knew our graph was going to be facing to the right, but p we counted out was 6. So since it was facing to the right, we know this is going to be a positive number. But in case you ever see one that's facing to the left, you have to make sure you put in negative for p. So that's something to remember. But that's our standard form right there. Okay, I'm just going to add to this problem here. Let's say it also asked us to identify the directrix. So to identify the directrix, If we know our distance for P from the vertex to the focus was 6, then from the vertex to the directrix should also be 6. So let me look at the graph again. So we're saying this distance is 6. P, the other direction, should also be 6. 1, 2, 3, 4, 5, 6 would be right here. But the directrix is a line. So if it's supposed to be a line, I just have to figure out whether it's vertical or horizontal. But because my parabola is facing to the right and my directrix can't actually touch my parabola at all, it's got to be a vertical line. Okay, there's my vertical line. I just need to identify the equation of this vertical line. So remember, vertical lines are always defined as x equals when it's vertical, and then the number here looks like it's at -4. So this is the equation of the directrix. If it was a horizontal line, it would be y equals whatever. So to identify the directrix, x equals -4 because we just counted whatever P was, that distance away from the vertex, the other direction from the focus. Okay, let's do another one. Okay, let's say this time the vertex was at -2, -4, and the directrix was at x equals 1. So let's draw this out again. All right, so we said the vertex was -2, -4, which is right there. And then they told us the directrix was x equals 1. So x equals 1, the x tells me that it's a vertical line, and then 1 would be right here. Okay, so knowing that, this should tell me that my parabola is actually going to face to the left, because it can't face to the right, because if I drew my parabola this way, then it would touch the directrix, and that's not allowed. If I had it face up, again, it would touch the directrix and not allowed. Down, same thing. So it has to be to the left. This is my vertex. So it's got to be this way somehow, which means the focus is somewhere in here as well. But that right there should tell me we already know the vertex. In order to write our equation, all we need is the vertex and P. So we have the vertex. We just need P. Well, P is that distance right there, the distance from your vertex to the directrix. So if we count 1, 2, 3, P equals 3 here. Okay, that was easy. Which means our focus should be, if I count 3 away from my vertex this way, this should be my focus. You know, just for funsies. Okay, so going back to writing the equation, we know our equation, because it's facing left, is going to be y squared. So y minus k squared equals 4p times x minus h. So I know p was 3, but because it was facing to the left, that distance then should be negative. Or not the distance, so p should be negative. So I'm going to have 4 times -3. And then x minus, my vertex was at -2, so this will become a +2, and y plus 4 for the -4 of the y value. Okay, then just multiplying this out. So we have -12 times x plus 2, and that'll be my standard form. The focus we said was going to be at that point. I think it was -5, -4. Okay, for my next example, I'm going to give you the focus is at 2, 4, and the directrix is at y equals -2. And finally, I want us to actually graph this one, like for realsies graph, not just like a sketch. So, first let's write the equation. Okay, so I've just sketched out what information they gave me. So they told me the focus was at 2, 4, and the directrix was y equals -2. So because it's y equals, now it's a horizontal line, and then at the number -2. Okay, which means our parabola has to face upwards here. So remember, the focus has to be inside the parabola. That means the vertex has to be somewhere in between the focus and the directrix. Should be right in between, because that's the whole definition of a focus and directrix. So right in between these 2 points should be right here. So if you just count towards the middle, or if you want to find the midpoint between right here and right here. Okay, so we know our vertex is going to be at 2, 1. I'm just going to write that in so that I remember it. And then it's got to face this way. But remember, this time I wanted to, graph it for real. So, okay. Now that I know that the parabola is supposed to face upwards, but I want to do an actual graph, so I'll save that for later. If the parabola faces upwards, that means my equation has to be x squared. So that'll be the equation that I use. I have the vertex, I just need p, so I can just count from my vertex to my focus, or from my vertex to the directrix, and it looks like that distance right there is 3. 1, 2, 3. Okay, and it's facing upwards, so that means p should be positive. So plugging that into my equation, along with the vertex, I have x minus 2 squared equals 4 times 3 times y minus 1 by plugging in the vertex. So multiplying that out, here's my equation in standard form. I got x minus 2 squared equals 12 times y minus 1. Okay, so from here, I just want to plot some actual points. That way I can graph my parabola more accurately. So in order to do that, we're just going to plug in points. We don't need that many. We know what the parabola is supposed to look like. So really, I'm just going to plug in like 1 or 2 points just to make sure I have the general shape of the parabola. So in general, what you want to do is plug in the number for whatever letter x or y is squared. So here I want to plug in a number for x because that's the one that's squared. It makes it easier to solve for y later when I plug in points for my xy chart. My vertex is at 2, 1. So you always want to choose points that are close to your vertex. It just makes your other value come out nicer. So I'm going to choose 0 because 0 is pretty close to 2. It should give me a good idea of how wide my parabola is going to go. So plugging in 0 for x, 0 minus 2 squared. Okay, so solving that out, 0 minus 2 is -2. -2 squared is 4. And then dividing both sides by 12 gets me 1/3 because 4 over 12 reduces to 1/3. And so y equals 1 1/3 if I add 1 to both sides. Okay, so now that I know for when x equals 0, y equals 1 1/3, so plotting that out, I get 0, 1 1/3 is right here. Okay. And I know I said I needed like 1 or 2 points, but really if it's a parabola, I know this is the vertex, shouldn't it be the same coordinates the other side, just reflected over our axis of symmetry? So since this point right here was 2 away from my vertex, if I go 2 away this way, I should also have a point here. So it turns out it's a pretty wide parabola. But there you have it. We're a little bit more accurate now just because we have how wide the parabola is going to be. So that's how you want to graph your parabolas. Just plug in a point for whatever letter is squared and choose numbers that are close to your vertex. Okay. So just one more example. Let's do... Alright, so we're given the equation y plus 2x squared plus 10 equals 8x plus 5. So we want to be able to write this into our standard form, which is that whole completing the square process. For this one, same thing. We want to start by grouping our x's and our y's, except because we only have one squared term in here, because in a parabola, you only have one side that's squared, either the x's or the y's. So that means you want to move the y, or like whatever's not squared, over to the other side along with the numbers. So I have 2x squared over here, so I'm going to move the x's over here, numbers and y's will go on to the right side then. So this will become 2x squared minus 8x, if I subtract the 8x over to the side, equals, I have the 5 that's here, minus the 10, and minus the y. Okay, with the stuff that's squared, that's where we want to complete the square. But before we can do that, we have to factor out the 2, because we can't use the completing the square formula with a number in front of the x squared. So this will be 2 times x squared minus 4x plus something equals, and 5 minus 10 is negative 5 minus y. Okay, complete the square. So b over 2 squared would give us positive 4, because b is negative 4. So again, if we add a number to this side, we also have to add it to the other side. But really, we're not adding 4, we're adding 8 because of the 2 that's in front. So we have to distribute, and that becomes an 8. So we're also going to add 8 to the other side. Writing this out as a square would give me 2 times x minus 2 squared, because remember this number is just b divided by 2, equals, and then I have negative y plus 3. I'm just going to write it in the right form. Okay, so you know how our standard form, we want it to look like, I'm just going to write it down here just so we see what it's supposed to look like. This is our goal. We're trying to make it look like this. So that means we want the y's in parentheses as well. So anything that we have in front of the y, we also need to factor out, which means that negative sign shouldn't be there. I'm going to factor out negative 1 to give me y minus 3 inside the parentheses. And then I don't need this number out front. I need something here though. So if I divide both sides by 2, now it's in standard form. So I've got the x minus h squared matching up like that. And then the 4p, that would give me a negative half there, and then the y minus 3. So this would be my standard form. For this problem, the vertex would be at 2, 3, because h, k. P here, because 4p equals negative 1/2, I should be able to divide both sides by 4 to give me p. So that means p equals negative 1/8. Since it's an x squared, it's going to face either up or down, but because p is negative, it'll face downwards with the vertex at 2, 3. Cool. And that's it for my parabola section. Good luck.